Landforms and their evolution. From the name of this chapter, we can figure out that in this chapter, we're going to read about the process in which various landforms were formed. Landform means land formation. So the Earth's surface is an uneven terrain. Somewhere you'll find plain land, then somewhere you'll find upland, like a mountain or a plateau. Then there are places where you'll find deep trenches or depression. So each landform, or we can also call it as terrain, has its own physical shape, size and materials. For example, mountains have rocky material inside because we have seen in previous chapter how mountains are formed, that is due to convection boundary, where the crustal plate come towards each other, and in doing so one plate coincides under another. Then a lot of rocks twist and turns, which elevates as a result, forming a mountain. Similarly, a plain land is formed due to millions of years of running water that erodes the surface and makes it a smooth leveled land. Here you will find very less rocks and more of sediment particles. So that's how every landform has its own physical shape, size and material. So in a nutshell, in this chapter we will learn how these different types of landform came into existence. Now here it says every landform has a beginning. This statement is very true. If you remember, we have read in the chapter Geomorphic Processes that all landforms are formed due to endogenic forces. These are the forces that come from the Earth's interior. Now landforms once formed may change in their shape, size and nature with time, sometimes slowly or fast due to continued action of geomorphic processes and agents. Here the geomorphic process that changes the shape of a landform is due to exogenic forces that is generated due to atmosphere and sun. Due to these two forces, that is endogenic and exogenic, we get to see new modifications in the landforms. And this modification does not take place in a blink of an eye. These take place in stages over a long period of time. We're talking about millions of years. And they go through tremendous development and changes through time. That is what is the meaning of the word evolution. The stages of transformation of landforms from one form to another after they are formed. I've made a short video on geomorphic processes. In that I have illustrated what geomorphic processes are and how it works. The video link is there in the description, do check it out. Now these changes in the landform that we spoke about, they happen due to two reasons: erosion and deposition. Erosion means wearing down or destruction, and deposition means piling up or constructional. So rain, wind, glacier, sea wave, all these are called exogenic agents, and they are the reason behind erosion and deposition of landforms. They create as well as break down a landform. These are called geomorphic agents, and they act over long periods of time and produces systematic changes leading to sequential development of landforms. Hence, we can also say that erosion and deposition are the two important aspects in the evolution of landforms. Now here it says most of the geomorphic processes are imperceptible. Now the meaning of the word imperceptible is undetectable, unobservable. In other words, something that is very hard to observe. Because nature has a very slow moment of development. I mean, when you look at a landscape, it's very rare that you can say, I have a before and after picture of this landscape. I'm not saying it's not possible. Many people have taken such pictures where you can see a landscape being totally changed in few years. But generally it's very rare. And it is because of the fact that this process is imperceptible. It takes usually thousands of years to see a noticeable change of a comparatively bigger landscape. Now why is this process imperceptible? Or in other words, why is it slow? The evolution of landforms is a slow and long process. And what makes it slow and long has both dependent as well as independent reasons behind it. We know that exogenic forces acts very heavily on these natural structures, especially structures in the form of folds, faults, joints and fractures. The exogenic forces changes them to a lot extent. For example, in a fold structure, the exogenic agents makes it steeper on the sideways, forming an intense sharp slope. In a fault structure, the exogenic agents can make the fault into a steep narrow valley. So you see the changes in the landform is directly dependent on the exogenic factors, and this entire process is imperceptible, meaning it takes a lot of time to see a noticeable change. And then there are independent factors. Now these are something that we read about and probably cannot see it, and that's what makes it an independent factor. So there are three controlling factors that independently influence the evolution of landforms. I want you to remember this because once you understand these factors, you'll be able to make your own analysis on many other geography related topics. Now these three factors are: the first one is stability of sea level. Now I'll tell you how sea level affects landforms. Sea level changes due to increase or decrease in the volume of water in the ocean. Now how does the volume of water in the ocean increases? It happens when glaciers or large sheet of ice melts because of increase in temperature. So when glaciers melt, the water stored in that glacier enters the hydrological cycle, meaning the ocean water will get more water. Its volume will increase. Now imagine if you have a tub and you will fill it up with water and then you keep adding more and more water. You'll notice that the wall of the tub will expand. It may also break at some point, but for argument's sake, let's just stick to expansion. Similarly, the increase in ocean water will exert pressure on the continental shelves. And not to forget, oceans have currents that will increase the horizontal push from time to time. So there'll be some minute changes in the continental landforms because of the sea level. The second one is tectonic stability of land masses. We have read about the theory of plate tectonics in previous chapters, and it is a universally accepted theory when it comes to the evolution of continents and oceans. We know that the continental and oceanic plates are divided in the form of some major and minor plates, and it's the movement of these plates that give rise to mountains and falls. And it is also the same reason why earthquake occurs. So tectonic stability of land masses is an influential factor in the evolution of landforms. The third one is climate. Now, mountain plateaus and other types of topography are formed due to endogenic forces, meaning the forces that are generated from within the Earth's interior. Now, once they are formed, they go through intense chemical and physical weathering due to exogenic forces like sun, rain, wind, glacier, waves, etc. Now, all these are dependent on climatic condition. And we also know that climate is not same everywhere. Temperature drops as we go away from the equator. With differences in temperature, Earth material goes through intense chemical as well as physical changes. Rocks break down due to constant heating and cooling condition. Then bacteria like mosses and lichens causes chemical reaction, and even that breaks down a rock. And this is all possible due to climate, and that's how climate influences the evolution of landform. So this is how these three independent controlling factors can upset the systematic and sequential stages in the development of evolution of landforms. Now we're going to read about some exogenic agents that reduce land masses through erosion, and at the same time it also helps in developing new landforms. The first exogenic agent is running water. You know the meaning of running water. Now there are two components to it. The first component is overland flow, which basically is an excess water that is generated due to heavy rain, storm, flood, melting, or any other sources that flows over the Earth's surface. In other words, when the amount of water accumulating on the land surface exceeds the infiltration capacity of the soil. So basically soil is porous and it sucks water, right? There will be a point after which it can no more take in any water. Then the water starts overflowing. So that is known as overland flow. The second component of running water is linear flow, which is basically rivers, streams that just flow naturally in a straight linear fashion on its own course path. So running water is considered the most important geomorphic agent when it comes to degradation of land. Now I'll explain how running water is such a powerful agent. Now we know that running water causes erosion, meaning it carries the soil from one place to another. And not to forget, the land surface has to be a little steeper, or we call it as gradient. It is only then the water will flow. So there has to be an upland. Now the higher this land surface is, the water flow is going to be faster, standard physics. So this is the infrastructure part. Now if the velocity or the speed of the running water is fast and vigorous due to the height of the land surface, because higher the land the faster the flow, this phenomena will cause erosion. Massive mud and rock debris will be removed from one place to another. In this case, all the mud and rock debris will go downwards and starts depositing in this lowland area. Now with time, the soil layer rises, then automatically the speed of the river decreases. So instead of flowing in linear path, it starts flowing lateral, meaning sideways. And then the process repeats. Water then finds a depression or a lowland and starts to flow there, and with it carries the soil. We call it lateral erosion of riverbank. and this way slowly the entire valley is converted into plains. Hence, when we see this question here, is complete reduction of relief of a high land mass possible? The answer is yes, it is possible. I've just explained the process. But the important point to note is that this geological change will take a long period of time. Even a lifetime would be less. Now, moments back we read about overland flow. It is also called as surface runoff. Let me repeat it again. In this, excess water due to heavy rain, storm, flood, melting of ice or other sources flows over the Earth's surface. Basically, overflow of water occurs on Earth's surface. This is what is called overland flow. Now, when overland flow occurs, it causes sheet erosion. By sheet, we mean a complete layer of soil which is like a sheet. It gets washed away. Now, why does it wash away? Because of the velocity or speed of the running water. Now, one thing to understand over here is that Earth's surface is irregular, meaning it's not smooth. Because of this irregularity of the Earth's surface, the water flow will take either a narrow or a wide path. And then water flows in this narrow and wide path. Due to the friction of the flowing water, many minor or major quantities of material, Earth's material, from the surface of the land are removed in the direction of flow. And when earth materials like mud and rock is removed, small and narrow rills will form. Rills are these designs that you see on the soil. Then moving forward, these rills will gradually develop into long and wide gullies. I guess we all know what gullies are. The gullies will further deepen, widen, lengthen and unite to give rise to a network of valleys. I know it must be a little difficult for many of you to comprehend as to what I said and showed. In a very short and quick way, I'll illustrate what this various stages of landscape looks like when they face running water. So in the beginning, rivers ideally starts from an elevated land portion and go straight in linear fashion. If we look at it from side view, the river flows in between V-shaped valleys. You must have seen those pictures where rivers flow in between mountains. This is called as youth stage. As time goes by, enough soil gets deposited and the speed of the river slows down. So instead of flowing in a straight linear manner, the river now begins to meander side to side and it enlarges its path, that is the river path. This is also known as lateral erosion and this is called the mature stage. Again, with time, due to lateral erosion, river enlarges the size of the valley so much that you can't really tell it's a valley anymore. So much meandering takes place that the river eventually converts the valley into peneplain. And if you notice, during meandering in between you will find isolated blocks of rocks, which are known as monadnock. This is the old stage of landscape evolution due to running water. Now the entire cycle can stop here, but if the river finds depression or a lowland, then the cycle would repeat again and form valleys, or in simple terms, the youth stage would repeat again. So I hope with this illustration you are now familiar with different stages of landscape, which happens all because of running water. Now we are going to read about erosional landforms. Now these are landforms that are created by erosion. Under this topic, the first one is valleys. We have just read about how valleys are formed. So valleys start as small and narrow rills. The rills will gradually develop into long and wide gullies. The gullies will further deepen, widen and lengthen to give rise to valleys. This is how valleys are formed. Now there are different types of valleys depending on shape and dimensions. Some of them are V-shaped valley, gorge, canyon, etc. Now a V-shaped valley looks like this. You see this pattern, it looks like the letter V. On the other hand, a gorge is a deep valley with very steep and straight sides. You see it's not V-shape. It's a narrow valley and you can see cliffs on both sides. Then we have canyon. A canyon is a steep step-like side slopes and they are as deep as a gorge. The only difference between a gorge and a canyon is that a gorge has equal width at its top as well as bottom, whereas in a canyon, the top portion is wider than the bottom. Remember this difference. The second type of erosional landform is plunge pools and potholes. Let me first tell you what potholes are. It is similar to the pothole that you see on roads, but in a riverbed, the scenario is different. When flowing water encounters bedload, a bedload is a heavy sediment particles that does not move. Because of this, the flow of the water is diverted. And the diverted flow of water forms something called eddy currents, which is a down-cutting current, and this current causes a depression in the riverbed, and these depressions deepen, Pebbles, boulders can get trapped in them. As a result of the eddy currents, the pebbles drill into the depression, making them more circular, wider and deeper. Now I'll tell you about plunge pools. When water flows over the waterfall, it creates a plunge pool at its base. Due to the force of the falling water, it creates a depression at the base. This phenomena is called as plunge pool. Basically, plunge pools are formed by natural force of falling water. The third type of erosional landform is incised or entrenched meanders. The meaning of the word incised is cut or cutting. You must have heard this word incisor teeth, the front four teeth we have for biting and cutting food. Have a look at this picture. In this, the river or stream is as usual flowing in between the landscape. We can call this landscape as a canyon. Do not mistake it as gorge. You see this side cutting on the landscape? This cutting is called incised, and meander is the regular turn of the river. So incised meander are meanders when the base level of the river has fallen to such an extent that the vertical erosion is so powerful that it starts down cutting the landscape, just like how I showed you in the pic. Now let's answer this question. What are the differences between incised meanders and meanders over flood and delta plains? In an incised meander, vertical erosion of the landscape is very powerful due to the gradient or elevation of the landscape. And if you see in the delta plains, which is a plain land, here lateral erosion, that is sideways erosion, is powerful. In plain or delta area, you'll not see much of landscape cutting. You'll see tributaries of river flowing laterally. But in incised meander, the river will go vertically long and erode the landscape to such an extent that you will start noticing cuts on the sides of the landscape. The fourth type of erosional landform is river terraces. We have heard this word terrace from the term terrace farming, in which many steps are developed in order to reduce soil erosion. So basically it's a landscape that looks like steps. In river terraces, these surface steps acts like a marking that represents old valley floor or floodplain levels. So terraces are vertical erosion, means the flow of the river is so strong vertically that it erodes the surface vertically. Now these terraces are of different heights depending on the irregularity of the landform. At the same time, they can be of same height. We call that as paired terraces. If the flow of the river is not uniform, then it develops into unpaired terraces. And there are a number of reasons behind unpaired terraces. Some of them are, number one is receding water after a peak flow, when there is a lot of water flowing and all of a sudden the volume of the water decreases. The river channel becomes narrow, and due to that, narrow gully formation takes place. As a result, we can see terrace formation. The second one is change in hydrological regime due to climate changes. Now with regards to climate change, there's always a concern about increase in ocean water, and that can cause flood, which in turn will cause unpaired terraces. Now the third reason behind unpaired terraces is tectonic upliftment of land. When a portion of Earth's surface is uplifted due to tectonic activity, that causes a huge change in the flow of river. When there is a change in the flow, that will cause unpaired terraces. The fourth reason behind unpaired terrace formation is sea level changes in case of rivers closer to the sea. When there is an increase in the volume of water in the sea, that excess water will sweep into the land through rivers. That will cause flood, and naturally unpaired terrace formation will take place. So these are the four reasons that can cause unpaired terraces. With this, we have now covered the four types of erosional landforms that exist due to running water. Now we'll read about depositional landforms that exist due to running water. The term deposition means accumulating of soil sediments. And how does it accumulate? Obviously, once rocks are eroded due to exogenic agents like wind, air, water, glacier, etc. And after that they turn into sediments. Then with the same exogenic agents, they get transported and deposited to another place. That's how depositional landforms are formed. The first depositional landform is alluvial fans. Now you must have seen this alluvial fans many times. It looks like this. When streams flowing from higher levels break into foot slope plains of low gradient, it takes the shape of a cone. Usually it occurs in mountain slopes or an area which is elevated, because that's how there will be a speed to the running water, and that's how sediments will be deposited on the foothill area. You will find many such alluvial fans in the foothills of Himalayan range, because there the glacier of mountains melts and converts into river streams, and that's how alluvial fans are formed. The second depositional landform is deltas. A delta is a landform that forms from deposition of sediment carried by a river as the flowing river enters slower moving or standing water. This occurs where a river enters an ocean, sea, lake, reservoir, or another river whose movement is comparatively slower. Due to the stillness or slow movement, the sediment starts to deposit. As a result, deltas are formed. The third type of depositional landform is floodplains, natural levees, and point bars. Now, what is the meaning of the word floodplain? An area or a plain land that is subjected to flooding. This area is especially a low-lying area adjacent to a river. So we are talking about this portion over here. And floodplains consist of sediments that are transported by a river. So just as erosion makes valleys, deposition develops a floodplain. So always remember, a river initially flows from a gentle slope area, meaning it needs a little gradient for that natural push. If the speed or velocity of the river is high, then it will transport large sized materials like big rocks and boulders and massive chunk of mud, and this is what forms the riverbed. As the speed or velocity of the river slows down, fine sized materials like sand, silt and clay are carried. That's why in hilly areas the riverbed consists of big rocks and boulders because of heavy flowing of river. And in plain area where the speed is comparatively slow, here you will find soft sand on the riverbed. So wherever you see soft silt and sand, that's a floodplain. And a riverbed is an active floodplain. And the area near the riverbed is called as inactive floodplain. And this region consists of two types of deposits, flood deposits and channel deposits. In plain areas, river flows laterally, and they often change their course. That's why they are called as river meanders. And the meanders gets filled up gradually with sediments, and this is called as channel deposits. And flood deposits are formed when a riverbed overflows and water in it spills above the bed. So because of this overspill, the water then takes the sediment to the side of the riverbed, and that is what is flood deposits. Now natural levees and point bars are also associated with floodplains. You see this picture? This is what is a natural levees. Natural levees are found along the banks of large rivers. They are low, linear and parallel ridges. During flooding, as the water spills above the bank, the velocity of the water comes down and large size and high specific gravity materials get dumped in the immediate vicinity of the bank as ridges. They are high near the bank and slopes gently away from the river. So always remember, the meaning of the word ridge is a long narrow land which is uplifted. And here it happens because of deposition. We have covered floodplains, natural levees, now it's point bars. Point bars are also known as meander bars. They are a depositional feature made of alluvium that accumulates on the inside bend of streams and rivers. So look at this diagram. When a river or a stream flow, it forms meanders. The highest energy is near the outer edge of the riverbank. The stream energy is much lower on the opposite side, that is inner side. Here it cannot carry as much sediments and becomes depositional. This is how it goes on to form point bars. They are almost uniform in profile and in width and contains mixed sizes of sediments. The fourth type of depositional landform is meanders. Meander is the flow of a river in zigzag curly turns. Basically, it's a curve in a river. The position of the curves changes over time. The river erodes sediments on the outside of the curves and deposits it on the inside of curves. If you see, meander is not a landform, but is only a type of channel pattern. Think about this. When a river flows from great height, because of the height, the speed of water is high and flow is usually straight. The moment the height decreases, the speed of the water becomes extremely slow. Water then flows leisurely and starts working laterally, sideways. Since the surface of the earth is irregular, the riverbank slowly transforms into a small curvature. The inner area of the curved deposition of sediments takes place, and on the outside, erosion takes place. If there is not depositional or erosion, then there would be no meanders. As meanders grow in deep loops, from here the river takes a shortcut, and this leftover curve is called as an oxbow lake. The fifth type of depositional landform is braided channels. Now girls have this hairstyle called braided hairstyle. It totally resembles how a braided channel flows. This is what a braided channel looks like. When a straight flowing river diverts its flow, lateral erosion takes place. Due to that, sediments get deposited that forms into these tiny islands. And these tiny temporary islands create number of water channels, which forms a braided pattern. So basically the water flow is divided into multiple threads. These threads, like streams of water, rejoin and subdivide repeatedly to give a typical braided pattern. So these were the 5 types of depositional landforms that exist due to running water. This chapter continues in the second video, so please take a break and get back on that.